I'm Professor Rad, and this is Precalc video 1-5, combining transformations. So in the last 3 videos, we've kind of been working in isolation, more or less, with different kinds of transformations that we can do on functions. So we had some outside transformations, those resulted in vertical changes. We had some inside transformations, those corresponded with horizontal changes. And then in the last video, we talked about some reflections. So reflecting over the x-axis or over the y-axis. Just as a reminder, if we add or subtract, that's going to be a shift. If we multiply or divide, that's either a stretch or a shrink. And inside stuff works the opposite way that you want it to. Outside stuff works the way that you do want it to. So if I'm adding inside the function, that's going to be not a shift to the right, but a shift to the left. And if I'm adding something outside a function, then that's going to be a shift up because that's what you would anticipate. So in this video, we're going to take all of that and combine it. We're going to make a fabulous mixed stew. So the main thing you need to know about combining transformations is that we're going to do the inside transformations first, and then we'll do the outside transformations second. So I'm going to do this first example by creating kind of a list of points and seeing what happens to them. And then we'll also examine that one by just kind of visualizing it. So if you need to pause and reflect on any of this, feel free to pause for a moment, and then we will jump right on into this first example. Ready? All right, here we go. So for the first example, we're going to sketch g of x, which is 2 times x minus 3 quantity squared by using transformations. So in this case, we would need to see some kind of work to indicate that transformations were used and not just like a table of points or a graphing calculator. Remember, we're building up skills and techniques that are going to help us with more complicated than just the squaring function in the future. So we want to make sure we're practicing those on familiar looking functions. That was a squeaky marker top. So g of x is indeed a transformation on the squaring function. So before I even start to think about what that is going to, the transformations that are going to happen, I need to visualize the squaring function. So I'm going to do that over here. You know, the squaring function makes everything positive when it squares it, so I don't need much of the negative axis. And then I'm just going to put maybe 5 nice points here. So going from -2 up to 2. So -2 squared is 4. -1 squared is 1, 0, 0, 1, 1, and 2, 4. Remember, when we do transformations, it's nice to have some, nice points for us to reference when we do our transformations. So here, I'm going to be using these 1, 2, 3, 4, 5 points as my nice points for reference. So this is our function f of x equals x squared. That's our base function. Now, we're going to be transforming it, so we need to know what transformations to do, right? So when I look at g of x now, I notice 2 things are happening to this function. I've got a multiplying by 2, and I've got a subtracting of 3. So following our guidelines, we want to do the inside transformations first. So that means we want to deal with this -3 first because it's happening inside before I do the squaring. And then we'll do the 2 afterwards because that's happening outside the squaring piece. So inside refers to horizontal changes and it works the opposite of your intuition. So subtracting 3, my intuition's telling me that means it's going to go to the left, which means it goes to the right. So first, we're going to shift right by 3. Second, we have this 2 on the outside of the function. So because it's on the outside of the function, that means it's a vertical change and it follows what we want it to. So since we're multiplying, it's going to be a stretch because multiplying by 2 seems like you're making it bigger. So we're going to stretch vertically by 2. Now remember, when you do a stretch, that means you're going to impact, in this case, the y values because it's a vertical stretch. So since we're stretching vertically by 2, that means we have to double the y values. Okay, so now we have kind of a list of what we're going to need to do to each of these points. We're going to shift and then we'll stretch. So if you want to do that visually, you can go ahead and do that. You can pause here and do that, and then compare your result to our final answer. For this example, I'm going to be making kind of a list of points, kind of take it a little bit slower so we can see what's happening. So we're going to start out with our original points. Then first we have a shift to the right by 3. And then we have a vertical stretch by 2. Now, it's always helpful when you're doing a stretch or a shrink to indicate whether that's a vertical or a horizontal change. Because if you just say, well, you're going to stretch it by 2, I don't know what that means. Are you stretching in both directions or in one direction? So I like to do that by indicating like this double arrow, right? It's a vertical stretch. So let's list out our 5 original points. So we had -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. Now we're going to take each of these points and move them to the right by 3. So if I'm at -2, 4, and I go to the right by 3, I'm going to go 1, 2, 3. I'm going to be here at 1, 4. -1, 1. If I go to the right by 3, it's going to take me to 2, 1. 0, 0 will bring me to 3, 0. 1, 1 will take me to 4, 1. And 2, 4 will take me to 5, 4. Do you notice the shortcut I was taking there? So the shortcut I was taking is because it's moving to the right by 3. That means I just add 3 to the x values. So -1 plus 3 will give me the 2. If I look at visually what's going on, 1, 2, 3, that's the same thing. I would get 2, 1. In this shift, we're not changing the y value at all. So all the y values stayed the same. It was just the x values that had the impact. Now for the second transformation, we're all done with our original points. Now we're going to be based off of these new points here. Our second transformation is a vertical stretching. So that means we're going to have to double all of the y values. So now all the x's from this column stay the same. So I'm just going to set that up. And all the y values get doubled. So double 4 and I get 8. Double 1, I get 2. 2 times 0 is 0. 1 times 2 is 2. And 4 times 2 is 8. Whew. So there we go. These are all of our new points. And since that's the end of our list of transformations, we should be able to graph them on our grid. Now, sometimes you may not have a graphing space provided for you, so you want to use the x and y values here to help you figure out your x and y axis. So in this case, if I were creating one on my own, my x values have to go from 1 through 5, and my y values have to go from 0 to 8. So here we can see, okay, here's my 1 through 5 with a little bit of buffer on either end, and then 0 to 8 with a little bit of buffer. So I'm just going to plot those points, 1, 8. 2, 2. Well, that's the ballerina point. 2, 2. 3, 0. 4, 2. And 5, 8. Now I'm going to connect them in the parabola form. And because it goes on forever, domain is all real numbers, I need to make sure to include my arrows at the end there. And there we go. So this is going to be g of x. That's a little offside my parabola, but we get the idea. So if you bypassed this table section and you just went kind of visually from here to here, how did you do? Did you get the same graph, or was your graph a little bit different? should be the same. So let's check just a couple points. For instance, this point here, 0, 0. If I were to shift that right by 3 and then double the y, it would end up at 1, 2, 3, 0. So it would end up at 3, 0. This one here. If I take this point from -2, 4, and I shift that to the right by 3, 1, 2, 3, and then I double the y, double 4 is 8. So we have 1, 8, that point there. So we should get the same points whether we use just a purely visual approach or whether we use a table approach. Again, either way, you want to make sure you're indicating how you're performing your transformations. So if you're going the visual approach, you still need to indicate what those transformations were that you were using. If you're going with the table, then you can just kind of indicate your columns. All right, so let's do another example. And this one I'm going to write out on the board, and then I'm going to let you try it on your own. And then we'll come back together, we'll reconvene and compare what we got. But for this function, for this graphing, I will point out there are 3 transformations to take care of. Something else that's helpful to remember is 0.25 is the same as 1/4. So you might want to think of that in terms of a fraction instead of as a decimal. That might help you figure out the transformation. And our basic function here is the square root function. So you might want to take a moment and jot down the graph of the square root of x. Find at least 3 or 4 good points to help you graph, and then transform those. You can use the table if you want, except instead of just your original and then first and second, you're now going to have another column for your third transformation. So you can make your table if you wish, or you can just transform it visually. So I'm going to ask you to pause the video here and work through it using those transformations. And when you think you've got it, you can unpause and check, and the answer should be on the board. Alrighty, so how did we do on this example? So I'm going to step aside if you want to take a moment and observe what I did, kind of compare it to your own work. And if you made a mistake, that's okay. We're learning. That's part of learning, is making mistakes. So if you did make a mistake, take a moment and try and figure out what it was you might have done. And then I'm going to walk through what I did and where some common mistakes tend to be. So pause the video, check your work, make sure everything is fine and dandy. Okay, so most often there's really 2 kinds of places where errors can happen. One is in a single transformation. So maybe instead of stretching by 4, you compressed by 1/4. So that would be like a single transformation place. That could be one place where you might have made a mistake. Another place that mistakes tend to occur is in the order of the transformations. So in this case, because we have this 1/4 x, and that's inside the radical, that means that's the transformation I have to do first. So I have to do the horizontal stretch by 4. Then we have 2 outside operations. We have this negating outside, and then we have +3. So outside transformations follow your intuition in the order of operations, which means I have to deal with multiplying by a negative, and then I have to deal with the adding. So my second operation, or my second transformation, is informed by this negative, and my third transformation is informed by the shifting, by the adding. And if you did those in a different order, you would get a different graph. So if your graph looks a little bit different, that might be one of the reasons why. So multiplying by a negative is going to result in a reflection. Since we're outside the function, that's a reflection over the x-axis. So that's a vertical reflection. And if for our last one, since we're adding 3, they work the way we want it to. So that's going to be a shift up by 3. Also, I'm going to take a moment just to apologize here. If you hear a sound that's like an airplane wanting to take off, that's my computer, which is being used to record all this. It's very humid today, so the fan is kind of working on overtime. So that's what you're hearing. Not much I can do about it. Just think of it as like soothing background noise, right? Hopefully, maybe. Okay, so we have our 3 transformations. I did sketch a graph of the square root of x to help me out. And when I did that, I had 4 points I was going to use as my reference. So I had 0, 0, 1, 1, 4, 2, and then it went off to 9, 3. All of those thinking they would be helpful. So I made my graph first, and then I went by my points just kind of as a check. But you'll notice when I went through these points, for the original point 9, 3, when I did that first step of stretching by 4, that meant I had to multiply the 9 by 4, and that gave me a 36. And I was like, no way I'm graphing that. I'm already up to 22. I don't want to go off the board. So I just discarded that point because it wasn't going to work with the graphing space I had. Now, if I knew there were additional horizontal changes that were going to happen, like if I knew there was going to be a big shift, then I would have continued because that would have made up for that big number. But I knew my only horizontal transformation was the stretch by 4. So I just got rid of it. And then I did my vertical reflection and my shift up. And that resulted in these points here. Okay, so we have one more example to do. And this example, I'm going to give you kind of a weird graph to look at instead of a known function. And we're going to do 4 transformations to it. Oh my gosh, can we do it? Yeah, we can do that. And we'll walk through this one together since it is so heavy duty. Alrighty, so it's time for our final example in this video, and it's a bit of a doozy. So we have this beautiful function, lowercase f of x, that's been graphed. And we've been asked to sketch capital F of x, which is 2 times the lowercase f of 4 minus x plus a 1. Now, it also tells us to sketch capital F of x on the same grid. So I kind of drew these purple lines to indicate to myself where everything was to make it a little easier to count out the movement. So because it's so humid and my computer wants to just kind of explode at the moment, I'm not going to be making a table of points for this problem. If you would like to do that, I'll tell you a good place to pause so you can do that and work through it. But this one I'm going to do just purely visually here. So the first thing I'm going to do, the first thing that stands out to me actually is this 4 minus x. I don't like that it says 4 minus x. I want the x to be first because that's kind of how we've been seeing our transformations so far. So I'm going to rewrite this as 2 f of, since I've got minus x, I'm going to have a negative x. And since this is a positive 4, I'm going to write plus 4 plus 1. So I'm going to start out by rewriting that function so that everything's in the correct order that I want it to be in. Next, before I start even to think about shifting and reflecting and all that stuff, I'm just going to think about order. That's it. What order do I do the transformations in? I'm not going to think about what those transformations are, just the order that they happen. So we have, first we do the inside transformations, and then second we do the outside. So I'm going to look only at what's going on inside f of x. So right now, when I look at what's going on there, I see 2 things. I see that I'm negating x and I'm adding 4. If I follow my normal order of operations, I deal with the negating first and then the adding 4. But inside, we're the opposite of the order of operations. So that means we have to deal with this plus 4 first and then the negating. So I'm just going to give myself a little note that this part happens first and this part happens second. So I know that whatever this is, that happens first, that happens second, and now we can move to the outside transformations. So looking only at the outside of this, I see that I have a 2 in front of the function and a plus 1. Now outside works the same way that your intuition and the order of operations tells you to. So outside, we're going to do this times first, and then we do the plus. So that means this is going to be our 3rd transformation, and then the plus 1 is our very last one. So before I even start to think about what the transformations are going to be, I think about what order am I going to do those transformations in, kind of give myself a little bit of a map. Then I can start to think about what those transformations are. So the first 2 are inside, so I know those are horizontal changes. Since I'm plus 4, since I'm adding 4 here and it's horizontal, that means I'm going to shift left. It goes opposite what I want it to. So first we're going to shift left by 4. Second, we're negating the x. Remember that that negative means a reflection. So since we're negating x inside the function, this is a horizontal reflection. Now for our third transformation, now we've moved outside the function because that 2 is outside the parentheses of f. So our third is going to work the way we want it to. So because we're multiplying by 2, that's going to be a vertical stretch. So that means all the y values get doubled. So we're going to double the y's. And lastly, we have our 4 here. That gets moved up 1 space. So the 1 means we're going to shift up by 1. All right, so these are going to be the transformations that we need to complete in order to graph capital F of x. Now, if you're the sort who wants to create a table to help you with each point along the way, this is where I recommend that you pause this video and do this. We have a few points here. We've got -1, 0, 0, 3, 3, 0. Then we have an open circle at 4, 1. So you might want to indicate that that's open in your table. Just put like a little open circle next to it, because we have this free floating point at 4, -3. So we have this weirdo down here. If you want to try doing this one visually on your own, get some practice in, feel free to do that. If you want to use the table, feel free to practice that. I'm going to walk you through my visual process right now. So let's go through this. So I'm going to start out with this point here at -1, 0. I'm going to shift it to the left by 4. 1, 2, 4. A horizontal reflection means I'm going to reflect it this way. So the x value is currently a -5. So it's going to become a +5. Then I double the y value. The y value is 0, so the y value doesn't change. And then I shift it up by 1. I'm going to go right here. So this point gets transformed over to here. Clear my mind for a moment so that I can reset. And then I'm going to use this point up here. So this point is at 0, 3. I'm going to shift it to the left by 4. 4. I do a horizontal reflection. So the x value is a -4, which means it's going to reflect over to +4. Then I double the y's. So the y value here is a 3. So if I double 3, I get 6. And then I shift up 1. So I'm going to go up here to 7. So this point gets transformed over to there. All right. Third point. So here we have 3, 0. We're going to shift to the left 4. 1, 2, 3, 4. A horizontal reflection. So it's at -1. So it reflects to +1. Double the y's. The y value is 0, so it doesn't change. And then I shift it up by 1. There we go. Okay, so that's our third point, 1, 2, 3. So our fourth point, this is the open circle one. So I have to remember to graph it with the open circle. I'm going to shift left by 4. 1, 2, 3, 4. I do a horizontal reflection. Well, the x value is 0, so it doesn't go anywhere. I double the y value. So if I double 1, I get 2. And then I shift up 1. So I'm going to actually right there. Oh, but it was an open circle. Gosh darn it. So we'll make an open circle there. Okay, and now we have this strange point that's all floating by itself. Shift left 4. 1, 2, 3, 4. Horizontal reflection. The x value is 0, so it doesn't change. I double the y, so I'm at -3, so now I go to -6. And then I shift up 1. So now I'm here at -5. Now I connect the points in the same manner in which they were connected in the graph. So these first 2 points ended up here with a straight line. Then we had kind of a curve coming down. Then we had a straight line connecting those. And then this guy was free floating. So that's our capital F of X. Now, in this case, I am going to do kind of a real quick reasonableness check. So what I'm going to do, I needed to double the y's at some point. So originally it had a height of 3. I'm not counting this one for this purpose, but here we had a height of 3 on that little hill. So if I double it, I should have a height of 6. So if I look at it, it had a height of 1, 2, 3, 4, 5, 6. So that is kind of a real quick reasonableness check for what the transformation should be, and what I ended up with is always a good plan to do. And then over here, this open circle and the solid circle had to line up vertically, which they do. So that's nice. And the space between them was 1, 2, 3, 4. So if I double that, the space between them should be 8. 1, 2, 3, 4, 5, 6, 7, 8. So you can kind of use that to help with to kind of make sure that, some of what you were doing is correct. And I'm always nervous about my doubling. My shifting, I'm usually okay with. It's the doubling that I like to double check. But if you like to double check your reflections, for example, you might want to kind of look at what's going to happen there, or you could kind of create a little shadow graph very lightly on the side after the shift. So that makes the reflection a little bit easier. Or you can make your table, whatever is going to work best for you and help support you in your transformations of functions. So that's it for this 4-video grouping of transformations of functions. In the next video, now we're going to move into algebra a little bit more, and we're going to compose functions. So looking forward to seeing you in that video. I'm going to give my computer a little bit of a rest now. So you can take a little bit of a rest too if you like. And I look forward to seeing you in the next one. Bye.